Okay, welcome to my channel. Today I am going to start a interesting topic, Bessel's function. Okay, so in HKDux there are exercise 29.1. I'm going to solve this. Okay, before that something need to be said today. Those who are new to this channel must subscribe because all the maths that I provide here. Okay, if you go through the entire YouTube, you will understand how much effort and time I have to spend on such content. Okay, so a little bit of support can be easily done, and I am happy and with that, and you will continuously receive videos from me also. So please subscribe this channel because this is completely new channel. Okay, if you want the solutions of Laplace transform, then there also a channel where I have already uploaded exercise 46.1. You can go there. Okay, I will attach the link. Okay, so today I am going to start the topic Bessel's function. Okay, so I am considering that you all go through the basic because I am not here to start any class. I am just going to solve the mathematical problems. Okay, so first of all, you all know, I think you all know that recurrence formula. Okay, here, one minute please. Here the recurrence formulas. Okay, this is very important. Plus orthogonality functions, etc., and some of these examples. I think you should read this. After that, you should come to this exercise. Okay, and I am here to solve this. Okay, so I am considering that you all know this. Okay, so now I am starting the first question, exercise 29.1. okay, first question. Here it is said that prove that j1x equal to x by 2 minus x cube 2 to the power cube into 1 factorial 2 factorial plus x to the power 5 by 2 to the power 5 into 2 factorial 3 factorial. Okay, no problem. Okay, so fine. So what do you all know? We all know that jn of x, what is the Bessel's function. Okay, we can write it. This is summation r equal to 0 to infinity minus 1 whole to the power r. Okay, by r factorial gamma of n plus r plus 1 and x by 2 whole to the power n plus 2r. This is the Bessel function, and I'm going to solve by using this condition. Okay, so we all know that you can write it n plus r plus 1 by n plus r factorial. Okay, so I have r equal to 0 to infinity minus 1 whole to the power r by r factorial n plus r factorial. Clear? Okay, x by 2 whole to the power n plus 2r. Clear? Now substitute n equal to 1. Okay, n equal to 1. So j1 of, why n equal to 1? Because it is said in the question j1 of x, and this is n equal to 1. Okay, so this is the left hand side. j1 of x equal to r equal to 0 to infinity. Okay, so minus 1 whole to the power r factorial, and what, n equal to 1, so 1 plus r factorial. Clear? And x by 2 whole to the power 1 plus 2r. I think it's clear. Now substitute the values. Here r equal to 0 to infinity, so at first substitute the value r equal to 0. So if you input this r equal to 0, so this term will be 1. Okay, and this whole term will be 1, and this will be r equal to 0, so 1, and the remaining part x by 2 plus, if you substitute r equal to 1, then this will be minus 1 by 2. Why 2? Because r equal to 1, so 1 plus 1, 2 factorial equal to 2. Okay, so minus 1 by 2 into this term x cube by 8. Okay, plus if you substitute n equal to, sorry, r equal to 2, then you will get x to the power 5 by 2 square 4 square into 6. Okay, now you can write dot x by 2 minus x cube by 2 to the power square into 4, okay, plus x to the power 5 by 2 to the power square into 4 square into 6 minus da, da, da. Clear? And from here you will get x by 2 minus x cube by 2 to the power 4 plus x to the power 5 by 2 to the power 6 into 2 into 3 minus da, da, da. Okay, so from here you can get x by 2 minus x cube by 2 to the power q into 1 factorial, okay, into 2 factorial plus x to the power 5 by 2 to the power 5 into 2 factorial into 3 factorial minus, so this is RHS proved. So this is the first math. Okay, now the second math coming later. I am coming to this math now. Number 3. Okay, here it is given that prove that J2 equal to J0 double dash minus x inverse J0 dash. Clear? Fine. Okay, 1 minute. Okay, so for proving this I need a recurrence formula. Sorry. Okay, so we know that x jn test equal to a jn n jn minus x jn plus 1. Okay, this is the recurrence relation. Okay, now substitute n equal to 0. If you substitute n equal to 0, you will get x j0 dash equal to minus x j1. Clear? So from here you can write j0 dash equal to minus jn, and you can also write j0 double dash, I mean is the second derivative, okay, equal to minus j1 dash. Okay, now I need another one recurrence relation. You all know that x jn dash equal to n jn minus x jn plus 1. Now here substitute n equal to 1 and you will get x j1 dash equal to j1 minus x j2. Clear? And from here you can write x j1 dash, and you all know that j1 dash equal to j0 double dash. Okay, here already I have proved. So substitute the value minus x j0 double dash equal to j1 minus x j2. Clear? Okay, now you can again substitute the value j1 equal to j0 dash. Okay, minus, obviously minus j0 dash minus x j2. Clear? Now x j2 equal to minus j0 dash plus x j0 double dash. Okay, and you can j2 equal to, can write also j2 equal to minus x inverse j0 dash plus j0 double dash. Proved. Here you can write that j2 equal to j0 double dash plus j0 double dash minus x inverse j0 dash. Okay, now this next math number 4. Here it is given that prove that ddx x j1 of x equal to x j0 x. Okay, so if you all know the recurrence relations, then this all maths will come to you very easy. Okay, otherwise it will be very difficult. So there is a recurrence relation that ddx of x to the power n jn equal to x to the power n jn minus 1. Clear? And if you substitute n equal to 1, then ddx of x, because x to the power 1 j1 of x. Okay, so x j1 of x, so LHS proved equal to x j n equal to 1, so 1 minus 1 x j0. Okay, so proved. Very easy. Okay, now the second math, next math 5. So here it is given that prove that ddx of jn square of x plus jn plus 1 whole square of x equal to 2 of n by x jn square x minus n plus 1 by x into jn plus 1 whole square of okay. So this is not the easy math, but okay, follow me. So you all know that one recurrence relation d dx of x to the power n jn equal to x to the power n jn minus 1. Clear? Okay, now substitute n equal to n plus 1. Clear? Okay, so d dx of x to the power n plus 1 j to the power n plus 1 equal to x to the power n plus 1 j to the power n plus 1 minus 1 j to the power n. Clear? Okay, now break this. So x to the power n plus 1 d dx of jn plus 1, clear, plus jn plus 1 into x plus 1 into x to the power n. X to the derivative of x to the power n plus 1, so n plus 1 into x to the power n plus 1 minus 1, so x to the power n. Clear? Equal to x to the power n plus 1 into jn. Clear? Okay, now x to the power n plus 1 d dx of jn plus 1. Okay, so we can write it x to the power n plus 1 d dx of jn plus 1 equal to x to the power n plus 1 jn minus jn plus 1 into x to the power n x plus 1 into x to the power n. Okay, okay, okay. Now I will divide it the full equation by x to the power n plus 1. Okay, so d dx of jn plus 1 equal to x to the power n plus 1, so jn minus jn plus 1 into x plus 1 jn plus 1 into, sorry, this is not x, this is the n. I have done a mistake. Okay, jn plus 1 into n plus 1 into x to the power n. Okay, so n plus 1 into x to the power n, jn plus 1 into n plus 1 into x to the power n. Okay, so x to the power n minus 1. Clear? Okay, so I can write it jn minus n plus 1 by x into jn plus 1. This is the equation number 1. Now again I am writing one another recurrence relation. We know d dx of x to the power minus n jn suman minus x to the power minus n jn plus 1. Clear? So break this. X to the power minus n into d dx of jn plus jn into minus n x to the power minus n minus 1 equal to minus x minus n j of n plus 1. Clear? Okay, so d dx of jn plus jn into minus n x to the power minus n minus 1 plus n equal to minus jn plus 1. Okay, so d dx of jn equal to minus jn plus 1 plus n by x jn. This is the number 2. Okay, now the second part, the LHS term. What it is given, that d dx of jn square of x plus jn plus 1 whole square of x. Okay, so split this, d dx of jn square of x plus d dx of jn plus 1 whole square of x. Clear? Now make derivative 2jn d dx of jn plus 2jn plus 1 d dx of jn plus 1. Okay, this is the number 3. Okay, so you can see here here ddx of jn and ddx of jn plus 1. Here is both value I have already evaluated, so substitute this. Okay, so substitute this and you will get 2 jn into minus jn plus 1 plus n by x into jn jn, okay, plus 2 into jn plus 1 okay, so jn minus n plus 1 by x into jn plus 1. Clear? Now you can write 2 equal to minus jn plus 1 into jn plus n by x jn square plus 2 into jn plus 1 into jn minus n plus 1 by x into jn plus 1 jn plus 1 whole square. Clear? Okay, from here you can write that 2 into n by x jn square minus n plus 1 by x into jn plus 1 whole square. Okay, so this is proved. Okay, for today I have already discussed 5 problems. Okay, next video I will solve another 5. Okay, before that I want to say about the problem 2, where prove that j02 equal to 0.224. okay, I want to say about that I put a lot of time 2 of a j0 of 2 equal to 0.224. okay, so what have I said? I put a lot of time behind it. In short, if the answer is wrong, then I should be disappointed. Also, I am doing a process. Okay, it can also be done by computer programming. You can try C++, Python, etc. Okay, so there is a function. I mean, you can say orthogonality relation or anything generating function what you said, but a relation exists. You should remind it. Jn of x equal to minus x whole to the power n into 1 by x ddx whole to the power n sin x by x. If you don't know this, I think if you have not any knowledge about this equation, then please go through it. You can get this from the examples. Okay, otherwise this is very important relation. Okay, so from here you can say that if you input n equal to 0, then j0 of x equal to, you can get sin x by x. And in the same process you should remember it, j1 of x equal to sin x by x square minus cos x by x. And similarly j2 of x you will get 3 by x square minus 1 sin x by x minus something. Okay, I can't remember. Okay, so I need j0 of x, j1 of x. So j0 of x equal to sin x by x. Okay, and here it is given that j0 of 2. So put the value and substitute and evaluate by the calculator. Okay, and same process j1 of x. So j1 of x equal to sin x by x square minus cos x by x. Okay, so j1 of 2 equal to, put the value 2. Okay, what you will get? I think the answer is wrong. Okay, for today I am ending the session. See you in next video. Like, share and subscribe.